Okay, so this is just a general part. It seems to be attached to kind of to example 3, but not really. So it's just a general how you find an equation for a trajectory for a general given speed of u and angle of theta. So if I draw out, and it says it's projected from the origin. So if I draw out, kind of imagine it being projected, let's pretend it's a vague straight line with the speed of u from our origin, and we convert it into its with an angle of theta above the horizontal, say above the horizontal, assumed. So using our SOHCAHTOA, we know the adjacent length cat should be u cos theta, going that way. Vertical velocity, initial velocity should be u opposite, so sine of theta. Think about our suvat variables here. So I'll just list what we have for a what we could consider for what's going on here. So this is about its position. So it's about path, which is about position effectively. So this is what we're looking for. S. We're going to consider it vertically and horizontally, not in vectors. So just as scalars. U. So we know it's going to be u sine theta and u cos theta, depending on which dimension we're looking at. I'll put them in the order if it was a vector it would be. V, we're not really interested in that at the same time. We're more interested in its position than its speed. Acceleration, again, 0 minus negative 9.8 if we consider it in terms of its component. And then time is a variable that we're looking at. So we'll leave that as t. If we consider that from a formula standpoint, we're going to want this. So this is the formula we use if we're considering a general trajectory formula. So we're going to need two of those. So one in the horizontal. Now again, I've talked before in videos about horizontal projectiles is effectively distance, speed and time, or s equals ut, because we've got no acceleration. So you could, and I think I will call it x and y. You could call it sx and sy. But because we're talking about a coordinate, we're going to talk x and y. So horizontally, the displacement, if we start from the origin, will be its x coordinate. So using s equals ut plus half at squared, its displacement will be x. Its initial velocity is u cos theta, multiplied by time. And then I've said before, the acceleration is 0, so that bit there is going to be 0. So we're just going to have x equals, to avoid confusion about this t and the theta, I'm going to call it ut cos theta. U times by t times by cos theta. Vertically there's a little bit more going on, so its position we're going to call y, i.e. the y coordinate. Its initial velocity is u sine of theta multiplied by time. And then we've got the rest of the formula which is relevant here, which is going to be a half times by a. So I'm going to leave this in terms of actually negative g, I think, because it leaves, it's a bit nicer if we're doing generalized things. So negative g and then t squared. Right? And again, I'll just rearrange the start so that it is ut, so we've got the two variables, sine theta, rather than it being sine, becoming sine of the angle times t. And then just take away, and I'm going to write it as gt squared over 2, I think. There's lots of different ways you can write that with the 4.9, so half of 9.8 for example, but I'll just leave it like that for now. And then what we want is a trajectory equation, okay? And that is where we want to combine the two equations. I'll just have a look at what's said at the bottom of the gap note. So it talks about these being parametric equations. So when we've got x and y usually, although not always, and then another variable, which is the angle, because you would know the u and you would know how long for a specific period, but the angle is the thing that generally you're going to look at changing. We can combine these in something called a Cartesian equation, where we just have x and y. So if you have a Cartesian grid, or you hear the word Cartesian, it means just in terms of x and y. So if I wanted to do that, well, I've got a variable in here which is t, which I can then get rid of, because that is something that's going to change. Yeah, so the variables, I guess, are t and theta at the moment. U is not, it would be a constant. I misspoke on that a second ago. So if I, for example, rearrange this equation to call it t equals, and that would be x over u cos theta, I could substitute that into here in the two appropriate places, and we could have what is called the Cartesian equation. I'll see if I've got room to have a whirl of that. So, different colour again. That means I would then have y equals u times by x over u cos theta times by the sine theta that was already there. Take away g over 2, and then that fraction squared. So x over u cos theta in there. And we end up with something, depending on whether you use g or minus 9.8. So you might be able to tell here on the first fraction the u terms are going to cancel out. So what we're left with is x, and then we've got sine theta here, which I can put over 1, and I've got divided by cos theta, so that's actually going to be x tan theta. Okay. And then in the second term, we've got minus, so we've got g, so I've got x squared, and then, so g, in fact I'll call it g over 2, and then we'll times it by, so we have x squared over u squared and cos theta squared, or cos squared theta. Obviously that can be combined. I've run it slightly out of room, so you can have, for example, x squared g over 2u squared cos squared theta. We're dividing by cos squared theta, so some of you might notice that we can use something in terms of sec squared theta there, and there's even further simplification that you might see in some questions, because sec squared theta and tan theta slash tan squared theta have got some links. But generally speaking, these two, which sometimes are with numbers and sometimes with all these unknowns, and it can be turned into something called a Cartesian equation, which you will see later on the year in your pure maths topic.